So this video is on chapter 6, classwork number 3. For this, we only completed this 6-21. Okay, and that 6-21 was this page and this graph. Okay, the rest of it we did not do, but we did submit once we completed 6-21. So you do want to submit it. Now the students did do this on their own with a little guidance. So I'm going to get us started on it, and you're going to want to pause, try the problem so that you know how to do it, and then come back and we'll go over the answers. So for this problem, this is called 6-21 planting trees. Charles and Amy are summer interns at a state park. They're helping to plant trees in an area where there was a forest fire. Charles's uncle owns a tree nursery and is willing to donate a 3-foot tall tree that will grow 1.5 feet per year. So I'm just going to kind of highlight that information here. Okay. So I have Charles. Okay. And we have a 3-foot tall tree that he's going to be doing, and it grows 1.5 feet per year. Okay. Amy goes to another nursery, but is only able to get tree seeds donated. According to the seed package, the trees will grow 1.75 feet per year. So Amy has tree seeds that will grow 1.75 feet per year. Okay. Now Charles plants the tree and Amy plants a seed on the same day. Okay, so I'm going to just highlight that they're starting at the same time. Okay, so they are doing it at the same day. Okay, Amy thinks that even though her tree will be much shorter than Charles's tree for the first several years, it will eventually be taller, be taller because it grows more each year. But she does not know how many years it will take for her tree to grow as tall as Charles's tree. Now, what they want us to do is figure out, will the trees ever be the same size? How many years will it take? Now, we want to know when they'll be the same size at the same time. And they want us to use 3 representations. Okay, those 3 representations, we're going to do a table, we're going to do a graph, and equation. Now, the first way the students did it in class was to make a table. So if we're going to make a table, we're going to set up the table this way. I'm actually going to make 3 columns for my table. Okay. So I'm going to have 3 columns, and let me just kind of shrink this out a little bit. I'm going to have 1 column, 2 columns, 3 columns. Okay. Now, this one here is really like our X, and these ones are our Y's. I can think of this as Y1 and this is Y2. One's going to be the Y for Charles. The other one's going to be the Y for Amy. Now, what does that X represent? Number of years. Y1, I'm going to have it be Charles. Okay, so I'm going to do Charles. Let's see, what color was I? I'm going to do him in orange since I had it highlighted in orange up there. So this is going to be the tree height for Charles. And this is in feet. Now let's put feet. My other one is going to be the tree height for Amy. And again, this is also in feet. And so we're going to make a table, and we're going to generate the data in this table and see when they're going to be the same at the same time. Now, what I'm going to do is, I don't know when that will be. So I'm going to start with 0 years. And let's say we go up to 10 to start with and kind of see where it goes from there. Hopefully we get it before 10. If not, we're going to keep going after that. So I'm just going to fill this out. up to 10. Oops. Okay, and maybe I have to go more. Maybe this is too much. We'll see. Okay, so that's going to be 10 years. We'll see what happens in 10 years. Now, for Charles, remember his tree was 3 feet tall, and then it grew 3 feet tall, and then it grew 1.5 feet per year. So I'm going to have his start with 3 here, and then I am going to be adding 1.5. So I'm going to do this on a calculator, do it on Desmos, do it on your phone, and I'm going to just keep adding 1.5, 4.5, and I add 1.5. I end up with 6, and so forth. So I want you to pause this and go through all of the ones for Charles. Okay, let's get up to 10. And I'm going to also do the same idea for Amy. Now, Amy, hers was a seed. It started at a height of 0, but it grew 1.75 feet per year. So we're going to keep adding 1.75, 1.75. So I'm going to have 1.75. And I'm going to take 1.75 and I'm going to add 1.75. And I get 3.5 and so on. So I want you to, like I said, pause after this, fill this out, come back and see if we got the same answers, and also see if we figured out where it was yet. If by 10 you don't figure it out, keep going until you find it. Okay, so welcome back. So on this, if I am filling this table out, okay, so for Charles, for year 3, I have 7.5, then 9, then 10.5, then 12, then 13.5, 15, 16.5, and 18. For Amy, okay, year 3, I have a 5.25, I get 7, 8.75, 10.5, 12.25, 14, 15.75, 17.5. So at this point, you see that they're not the same anywhere. Now, a lot of the students were thinking that they're the same here because you have 10.5 in both of these, but this was year 5 for his. At year 5, hers was only 8.75. Year 6 was when hers reached that. So we want to know, when are they the same? And you'll remember that hers was starting smaller, and you see each time hers is still less than his. So we need to keep going. Okay, so if you haven't gotten already, pause and keep going and just see if you can find it. Okay. Okay. So 11, 12, 13. I'm running out of space here, so let me at least fill out this much, and then I can start a new set of columns if I need. Okay, so for year 11 for Charles, I got 19.5, 21 and 22.5. Okay, for Amy, for year 11, I ended up with a 19.25, a 21, and a 22.75. So what's happening here is I am getting right here at year 12 the same height. You see that before 12, his tree was taller. Every single time it was taller than hers. At year 12, they're the same. Now, all of a sudden, hers is going to be more than his. It's going to continue being more than his. So from this table, okay, we see that they are going to be the same height year 12. So year 12, both are 21 feet. So I just found that using the table. Now, what they want us to do also is to do a graph. Okay, do a graph. Now, I do have these points right here at this point. So what I'm going to do is I am going to come up here to where the 3 bars are. And I'm going to make this two side by side. So I'm going to make it 2-page view. Now, when I do that, sometimes it puts a cover page first. Right now, mine didn't, but if it's because I had it out of that mode a second ago when we're doing this in class, but you'll notice here, this is what it's going to usually do. It's going to put this one first. I wanted these two next to each other. So if that happens, just come here and click or unclick, depending on what you want, this show cover page. And now they're next to each other. And now I can kind of do this. Now, what we can do is if you're doing it from your table, only graph the nice points. And what do I mean by the nice points? What I mean by the nice points is this. For example, 0,3 would be a nice point. 2,6 would be a nice point, as opposed to 1,4.5, 4,9, 6,12, and so forth. Now, when I'm dealing with Amy's, I would be dealing with 0, 0. I would be dealing with 4, 7. I would be dealing with 8, 14, and so forth. And then plot those. Okay. Now, let me come here and let me do Charles. So I'm going to do it as if I didn't have the table. So if I didn't have the table, so right now you can graph them using the table, okay, and then pause and come back. Now I'm going to graph it as if I didn't have a table. And I know that in this case, let me just label this. This side here is years. And this here is feet. Okay. And so for Charles, what I know is that his tree started at 3 feet. So I'm put a point 0.03. And then it increased by 1.5 each year. So 1.5. This is a half and 1 each year. Now, what you'll notice is this isn't nice, but from here to here is nice. So I'm going to kind of look and see, how did I move? I went up 1, 2, 3 every 2. So I'm going to do that instead. So it's increasing by 1.5 every 1 year, but it's increasing by 3 every 2. So I'm going to go 3 every 2, and I'm just going to keep doing this. Okay, 3 every 2, 3 every 2. Okay. And then I'm going to connect these. So let me get my line. And I'm just going to extend my line a little. So I'm going to come here and click and extend my, oops. Okay, there's my line. Okay, so that is Charles. Okay, I'm going to put C for Charles. Now for Amy. So Amy, hers started at 0, 0. And hers was increasing by 1.75 every year. Well, that's not going to be nice to graph. So if I come over here and I remember I've got my table here, I added 1.75, I added 1.75, I added 1.75, and here it's nice. So I'm going to graph this 4, 7. Okay, so I'm going to come over here, 4, 7. Now, how am I moving from here to here? I'm going up 1, 2, 3, 4, 5, 6, 7 every 4. And so that's what I'm going to do. I'm going to keep doing that instead of plotting all those points. 1, 2, 3, 4, 5, 6, 7 every 1, 2, 3, 4. You can see hers is below his still. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. You see they meet. Let me just do one more. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4. Now it's above. And I'm going to connect those. And you see that they did cross. These crossed. And these crossed right here at, whoops, this point. This point right here. And what is that point? If I'm looking here, I'm counting over, it's 12, 21. So this point is 12, 21. And 12 what? 12 years. What's the 21? 21 feet. So I got my answer from a table. I got the same answer from my graph. The last thing they want us to do is an equation. I'm going to do the equation over here. So what I'm going to do is I'm going to write 2 equations. I'm going to write one equation or one situation. I'm going to say it this way, one situation, one expression for Charles, and then I'm going to do one for Amy. So for Charles, what we know is his tree started 3 feet tall and it grew 1.5 each year. And what I'm going to do is I'm going to have X the number of years in both his equation and in Amy's. Okay, so now for Amy's, if I do one for Amy, her tree was a seed. It started at a height of 0 and it increased by 1.75x. Now I want to know when these are the same. So what I'm going to do is I'm going to set them equal. I'm going to take 3 plus 1.5x and set it equal to 0 plus 1.75x. Now I really don't need this 0 here because 0 plus anything, okay, is gone. So I can just solve this. And let me just move this over a little. Okay, 1.75x. So that's my equation. Okay, and now I'm going to solve this equation. So again, this is my equation, and I'm going to solve it. So I'm going to solve for x. So I'm going to subtract 1.5x, subtract 1.5x. And when I do, I end up with 3 is equal to 0.25x. I'm going to divide both sides by 0.25. And so when I do that, I actually end up with 12 when I do that math. So you see I got x is 12. Okay. Now to figure out what they are, how much they are, I can put this into either this equation, and if I do that, I would have 3 plus 1.5 times 12. If I do that, 3 plus 1.5 times 12 ends up giving me a 21. If I put it into the other equation, so instead I put it into this equation, I'm going to get basically 1.75 times 12. And when I put that into my equation, I also get a 21. So I set up an equation. Okay, I wrote an expression for Charles's tree and I wrote one for Amy's tree. And I set them equal because I want to know when they are the same. When I solved, I got x is 12, which was 12 years. Then I took this 12, and it doesn't matter which of these two I put it into because I'm going to get the same in both. And you see I did. I got 21. Then we submitted it. So this is all we got through in class. So you can do the same and submit.